Hello, grade 7. So this week we are starting with a new chapter, chapter 4, called Density. And as you can see, I have written here, I heart density. You might ask why. You'll find the answer in today's lecture. So these are the objectives that we will be covering during this week. So you guys will be able to determine the density of any substance. It could be a solid, it could be a liquid, and you'll be able to identify the SI units and other units of density. Now, before moving on to density, let's remind ourselves with the mass and the volume. So the mass of a solid, you guys remember how we get the mass of a solid? We either put it on a digital balance and we read the value, or we put it on a two-arm balance and we find the total mass that is right here. Whereas the mass of a liquid, we find the mass of the empty container first, and then we fill it with the liquid. We find V2, which is the mass of the filled container, and then to find the mass of the liquid, it will be V2 minus V1. I can use a two-arm balance, or I can use a digital balance for it. Okay, so this is the mass. Whereas the volume, you guys remember how did we find the volume of a liquid? We used a graduated cylinder. So we poured the liquid in and we looked at the bottom of the curved line. And yeah, that's it. This is how we find the volume of a liquid. Whereas for a solid, if the solid has an irregular shape, we can simply bring this graduated cylinder filled with water, and then we put the solid, we introduce it inside this graduated cylinder. So we read V1, volume of water, we read V2, volume of water and the solid, and then we find V, which is V2 minus V1. But sometimes a solid can have a special shape like the rectangular prism or the cube. So for us to find their volumes, we simply use these formulas, which we already took in the previous chapter. So M is for mass and V is for volume. And if I put them together, I'll get a heart. So mass over volume, it makes a heart. And this heart is actually the density. So the density is the ratio of the object's mass by its volume. And this is why we love density, because basically this is its formula. So density is equal the mass over the volume. It is the ratio of the body's mass by its volume. Now, since the mass, I can write its symbol as M, and the volume, I can write it as V, I'm not gonna write density every time. It must have a certain symbol. Yes, it does. Its symbol is called rho, and it looks like that. It is a Greek letter. Okay, it's like a small p, you can say. So this is the density. We represent it by this symbol. So the density equals to the mass over the volume. Now, as for the definition, it is the ratio of the mass by the volume. And as a formula, I can write it rho, which is like a small p, equals mass over volume. Guys, let's see what is the SI unit of the density. So you guys remember what is the SI unit of the mass? It was kilograms. And the SI unit of the volume, it was cubic meter or meter cube. So basically I have kilograms over meter cube. So what is the unit of the density? That is it. So it is kilogram per cubic meter. Okay, so density, its SI unit, is kilograms per cubic meter, the mass in kilograms, and the volume in cubic meter. Now, guys, click on the simulation and let's go to the lab. So it's gonna open up to this website. You guys can see this lab. We have different solids. So we're gonna start with finding the density of a solid first. What is the formula for the density? Let's remember. So density equals mass over volume. All right. So for me to find the density of any object, I need to find its mass and its volume and just substitute them. Then we can find the density. So you can choose any object that you want. I will be choosing the crown. So as you can see, I need to find the mass and the volume of the ground. I have a digital balance right here and I have a graduated cylinder. So first, I will be putting the crown on the digital balance to find its mass. You can see that its mass is 840 grams. So 840 grams, this is the mass. Now, how can I find its volume? I have initially water, its initial level in this graduated cylinder is 400 milliliters. Now, when I introduce this crown, it jumps to 500 milliliters. So what is the volume of the crown? If it was 400, then the level became 500. Then the volume of this solid or the crown, you guys remember, it is V2 minus V1. So it is 500 milliliters, not minus 400 milliliters, and that is equal to 100 milliliters. This is the volume of the crown. Okay, now milliliters is the same as a cubic centimeter. So I'm going to use this unit. All right, so the volume is equal to 100 cubic centimeter. And if you use your calculator, you would get 8.4. Now, what is the unit here? What do you guys think? If it's in grams, if the mass is in grams and the volume is in cubic centimeter, then the unit of the density is gram over or per cubic centimeter. Just like that. Now, you guys, you can try different solids and practice finding their density, just like I did, okay? All right, now let's solve an application on a particular type of solid, which is a cube in this case. All right, so if I have a cube, then I can find the volume using the formula, all right, without using the method of V2 minus V1. So for me to find the density of the cube, I have to find, first of all, the mass, and then I have to find the volume. So what is the mass? The cube is already placed on a digital balance, so it reads 0.6 grams. So this is the mass. The volume, you guys remember, for a cube, V equals A times A times A. And you can see that A is equal to 1 centimeter, so it is 1 centimeter times 1 times 1. And the answer is 1 cubic centimeter. Perfect. Now, how can I find the density? Density equals mass over volume. The mass is 0.6 grams, and the volume is 1 centimeter cube, so the answer is 0.6 grams per centimeter cube. Okay, so this is another application that you can practice. Now, to understand density more, I will be going to this new lab. Okay, so you guys click on this and join me in the next slide. Okay, so it's going to take us to a different lab. You guys can see we have a certain material right here. In this case, we have polystyrene. It is like a foam material which is light. We have different materials. We have aluminum, we have wood, we have slate, which is like a type of rocks. And yeah, so I'm going to choose polystyrene. All right, so basically I will be putting it on this investigation table and it will tell me the mass and the volume of it. All right, and I will be finding the density of this big piece of polystyrene. Okay, so density equals mass over volume, which is 7.28 grams over 36.4 cubic centimeter, and it will give you 0.2 grams per centimeter cube. Okay, so I will put it back and I'm gonna slice it. So you guys see we have different pieces, but I'm still working with the same material. It is still polystyrene, but now I have smaller pieces. So I'm gonna take this one, which is a smaller one than the last one, and I'm gonna put it right here. So you guys see it has a certain mass and a certain volume. Let's try finding its density. Okay, so for the second piece, density, which is mass over volume, it is 2.28 grams over 11.4 centimeter cube. And if you try this with your calculator, you would get 0.2 grams per centimeter cube. What? I have the same density for both pieces, but the first piece, it was a big piece, and now this, it is a smaller chunk, and they both have the same density. Guys, if you try another piece, you'll get the same density. If you try this one, you'll get the same density. So, what can we conclude? We conclude that the density is a property of matter and that every substance, it has its unique density. Okay, so even if I took a big piece, I will have exactly the same density if I took a smaller piece, although the mass and the volume, they differ. But once you find the density, you'll find that it is the same. So we've already done this before. Okay, I'm gonna continue this application by adding another part to it where we bring another box made up from the same material. Both are wood, but it is a smaller box. You can see how small it is. So it will have a different mass and a different volume. So let's write down its new mass. Okay, so density equals mass over volume. The new mass is 0.075 grams, and the new volume, it is simply A times A times A, so 0.5 centimeters times 0.5 centimeters times 0.5, and we will get 0.125 cubic centimeters. So mass over volume will give us also 0.6 grams per centimeter cube. So even if the size is different, the mass is different, the volume is different, but I'm still dealing with the same material, I will be getting the same density. So it is like a property for this material. Okay? So to sum things up, let's write the steps how we can find the density of a solid. First of all, we need to find the mass using a two-arm balance or a digital balance. And then we need to find the volume. We find it by calculations if the solid is a rectangular prism or a cube using the formulas, or we find it by liquid displacement if the solid has any shape. In this case, V2 minus V1. And then we find the density by using the equation rho density equals mass over volume. Moving on to the density of a liquid. It's not any different. I'm still using the same formula. The only thing that is different is how am I finding the mass and the volume, and that's it. So this is actually found in your books, page 35. It says use the digital balance to measure the mass M1 of the graduated cylinder. So you can see M1 equals 190 grams. Now, this is the mass of the empty graduated cylinder. Now I'm gonna pour 10 milliliters of water in the graduated cylinder, and we're gonna find mass M2, which is the mass of the water plus the graduated cylinder, and it is 200 grams. So deduce the mass of the liquid M. The mass is M2 minus M1, which is 200 minus 190, and that is equal to 10 grams. Then they say calculate the density of water. So density equals mass over volume, and we have the mass equals 10 grams, and the volume I can basically read it, which is 10 milliliters and the same as 10 cubic centimeter. You guys can put milliliter or centimeter cube, but I'm using this one. I will be explaining this later. So this is equal to 1 gram per centimeter cube. So what is the unit of density? In this case, it is gram per centimeter cube. So to sum things up, for the density of a liquid, to measure the density of a liquid, we need to determine the mass by placing the graduated cylinder on a balance and measure M1, and then pour the liquid inside the cylinder and measure M2, and find the mass of the liquid, which is M2 minus M1. Now we need to find the volume by pouring the liquid into a graduated cylinder and measuring the volume. Finally, we find the density by using this equation, rho equals mass over volume. Moving on to the units of density. You guys saw that we have the SI unit, which is the kilogram per meter cube, and we have another unit which we used in all the applications in this lecture, and that is the gram per centimeter cube. Okay, so we have these two units. We have other units, but we will focus only on these two units. Now, how can we convert between them? Like if I have the density in kilogram per meter cube, how can I find it in a gram per centimeter cube? It's really simple. Okay, so I'm gonna give you the method and then you will simply just know the conversion table and that's it. So if I have 1 kilogram per meter cube, as if I'm saying kilogram over meter cube. Okay, now I want to convert this to gram over centimeter cube. Okay, let's convert the kilograms into grams first. So from kilograms to grams, I multiply by 1,000. And then let's convert the cubic meter into cubic centimeter. So from cubic meter to cubic centimeter, we multiply by 1,000 and then another 1,000. Okay, now you guys find the answer for this one. Let's try finding the answer. It would be 0.001. Okay, or it is simply 1 over 1,000. Okay, so going from kilograms per meter cube to grams per centimeter cube, I divide by 1,000. Okay, and going from gram per centimeter cube to kilogram per centimeter cube, I must multiply by 1,000. And this is how you get this table. You will simply just memorize this one. Okay, no need to go through what I just went through every time you want to convert. No, just know that this is how we convert between these two units. And the last thing that I will be speaking about, and I will explain this more in our live session, is that we know that the density is equal to the mass over the volume. Okay, we know this so far and we are very good at it. We know how to find it and that's perfect. Because usually I have the mass and I have the volume and I need to find the density. This is how it works. This is not the case all the time. Guys, sometimes I have the volume and I have the mass and I have the density, but I do not have the volume. And other times I have the volume and I have the density, but I do not have the mass. Can I find the mass? Can I find the volume? Is there a way where we can play with this formula and, just so that I can get volume equals to something or mass equals to something? Yes, there is. And this is where I introduce this lovely triangle. Okay, so you guys can see this triangle. It will always look like this, okay? At the top, we have the mass, and then at the bottom, on one side, I have the density. On the other side, I have the volume. Now, what is so special about this triangle? I'll tell you. First of all, this is the mass in kilograms. This is the volume in meter cube. These are the SI units, okay? And the density in kilogram per meter cube. These are the SI units. Now, we have other units. We said grams, gram per cubic centimeter, and cubic centimeter for volume. Now, how can I use this triangle to get the mass or the volume if I was asked to? Okay, for me to find the density, you guys already know that density equals mass over volume, but let's use the triangle. Density equals mass at the top over the volume at the bottom. It looks like it. Okay, so they look like a ratio. Mass over volume. Great. Now let's try to find the volume. Come on, guys. So it is mass at the top and density at the bottom. So I have volume equals mass over density. That's perfect. Okay, this is another one. How about if I want to try to find the mass? It is at the top. Yes, it is simple. So mass is equal density times the volume. Mass equals density times volume. Okay, so using this triangle, I can come up with three formulas. Okay, and I can use the three of them. It depends on what exactly I'm trying to find. If I want to find the mass, I can use this one. If I want to find the density, I can use that one. And if I want to find the volume, I will use the third one. Okay, and yeah, so that's it. We're done with this week's lecture. I hope you guys found this easy. If not, we have our live session. This lecture will be explained more and I will be there to answer all your questions. Study well, take care, and bye-bye.